Hey guys, it's JM. I want to talk a little bit about Bladebit Disk. We announced a couple weeks ago the Chia beta program, and Bladebit Disk will be the first product that goes through that. We are going to be collecting email addresses and sending out some beta builds of the GUI that have some of the Bladebit 2 functionality in there, and people can opt in to give their system information and logs to us. This will help making performance improvements to Bladebit quite a bit easier because we'll have lots of data. You can see on the blog post that I wrote a couple weeks ago, we talked a little bit about plotting and why Bladebit Disk is important. I did want to touch on a few things about kind of the background of like why we thought we wanted to do this. Um, First, obviously, Harold joined Chia, and that's been amazing. He's the author of Bladebit, and he's made some modifications of Bladebit. We've obviously integrated the GUI, and Bladebit is the fastest way to plot today. It's all in memory, but the problem with Bladebit is it takes a tremendous amount of DRAM. So you need 416 gigabytes of DRAM to do full in-memory plotting. Now, rather than Harold spending a bunch of time working on that to make it, say, for instance, 20% faster, or maybe we can get the system requirements down to 256 gigabytes with some fancy buffering and DRAM placement. There's quite a few things that Harold could work on. We decided it would be interesting to do a disk-based plotter. And when we did this, obviously, the competition out there is madMAx, and so we wanted to set the requirement and goal that we want to beat madMAX on, say, 80 or 90% of system types. And we wanted Bladebit Disk to work a little bit better on consumer SSDs. So the idea was we would make it kind of low memory requirements, but we wanted the memory requirements to scale, that if you have more memory, you can cache more of the writes and reduce the disk writes and get better performance. Now, in Bladebit Disk, if you have over 99 gigabytes of DRAM, then you can cache all of Temp2 in DRAM and significantly speed up the plotting process. So, and when you do that, today I measured the amount of disk writes. Bladebit Disk is a little bit better than madMAX, about 1.2 terabytes of disk writes for a K equals 32 plot. If you do have greater than 99 gigabytes of DRAM, it reduces that to 381 gigabytes of host writes. Now, this is still pretty hard workload for a consumer SSD. There are some consumer SSDs that have decent post-cache write speeds. Some of the newer Gen 4 ones, like even like the Samsung 980 Pro, generally do pretty good. Now, if you use this cache and you have sequential I/O and the write amp is 1, then you actually get really good endurance out of these even 1 terabyte consumer SSDs. Now, a 980 Pro 1 terabyte, I've seen them on sale for about $100. You can get a 1 terabyte used data center SSD on eBay for about 60 to $100. So this is a kind of a good target for entry level, mid level plotters. It's somebody that just has a standard 8 or 16 core desktop and they want to add an SSD so they can do some plotting. Now, we wanted that performance to scale, and the sequential write idea was a way to see if we could reduce the write amp, and even on drives that are kind of small that have higher endurance and higher performance, but also give it a way to make it easier on some of these consumer SSDs. Now, these are hard when you go out and architect software products and figure out this is what it should look like. In practice, we actually, in the very first alpha, had to scrap some of the methods that we use for sequential writing. It turns out, we were writing, small sizes of I/O, like 256 or 512K, these bucket slices, and writing sequential reads and writes back and forth to the drive. Some drives didn't like that many context switches, and performance kind of suffered. So, we've implemented now 64 buckets in the Alpha 2. This gives a little bit bigger chunk size. Now, the way the buckets work in Bladebit Disk is you take a whole table and break it into buckets. In the case of like 64 buckets, the file size ends up being a couple hundred megabytes. This is much better. So the drive will read a couple hundred megabytes into memory, sort it, write it back to disk, and then it does this all sequentially, and so that the write amp stays 1. So for this, there are obviously these system types with 120 gigabytes are going to do extremely well in Bladebit Disk. But the other thing that's even more exciting is if you have like even one PCIe Gen 4 SSD that has good write bandwidth, you'll be able to get really, really good plot times, even with 16 or 32 gigabytes of DRAM. So I'm excited to see what the community puts together for a bunch of really awesome, low budget system types. I'll talk a little bit about kind of the budget build and some of the other system types that I did in the blog here in a second, but and kind of the background on that. But the idea is that you want to be able to max out the CPU performance of a system, Now, it is plotting. Plotting is a tough benchmark. You're still going to need good CPU performance. You're still going to need good memory bandwidth. You are going to need a good disk that's designed for plotting. I mentioned high endurance is optimal and preferred, high sequential bandwidth. Now, in Bladebit Disk, that doesn't matter. It didn't matter as much in madMAX. In madMAX, it really was your sustained sequential write, sustained write performance that kind of dictated the plotting performance. The reads, got cached by the kernel, and it wasn't too much. In Bladebit Disk, all the writes are direct I/O, so they're not getting cached by the kernel. And this is really important because if you're writing these phase one and forward propagating, you're not going to be caching a lot of that data. So it is optimal, but if you aren't using a lot of cache, you need an SSD with good read and write bandwidth because you're moving data back and forth between the drive and the memory. And PCIe Gen 4 and other high performance, high bandwidth stuff for drives really shine in Bladebit Disk. And this was some of the some of the data center stuff I was testing early on in the alpha, which is like RAID 0 arrays of NVMe drives. These all performed extremely well with Bladebit Disk. Now we've optimized it so if you have one or two drives, even two NVMe drives in RAID 0 could max out like a 32 core system. So we think this is a pretty reasonable expectations for kind of people building anywhere from low end, entry level plotters on desktops to kind of mid level servers to kind of high end workstations. So I'm going to talk a little bit about the performance. We did measure a few more systems since I wrote the blog, but I think we have some really interesting data, and I'll talk a little bit more about kind of what we are going to do next. So I did do some quick benchmarks on these systems that were not Chia related, just to get some idea of what the performance would be. We have a hypothesis that when you run a pass marked CPU test, you'll have your total CPU marks, and then they have a sorting test and then a memory threaded bandwidth test, and it kind of gives you some nice idea of how the performance should scale on something like plotting. Obviously, this is not taking into account your disk performance, but without disk, these are the two most important kind of CPU metrics that matter for plotting. You can see here the Ice Lake, this Xeon Gold 6338 is the highest memory threaded performance, and the AMD Threadripper Pro did actually beat out my Ice Lake for total CPU marks, but you can see that's this green, but the memory threaded bandwidth is the highest on the Ice Lake because it has two CPUs with eight channels of DDR4 3200. Now the system I added here recently, I just mentioned I got this new 5950X system, and now the threaded memory bandwidth is about 45 gigabytes per second is what we should be getting on the system, which actually makes sense. You have two channels of DDR4 at 3000 megahertz, so that's actually spot on, right? But as you saw, we're not quite seeing that with Bladebit C++ memcopy. So there may be some. Now we don't generally see. Generally, I see about half of what this passmark memory bandwidth is reporting. I see about half that when we're doing real world stuff like memcopy in Bladebit. But it's a good benchmark and kind of interesting information. Now, if we look at the plot time comparison, so let me shrink this here. So this is interesting. I mentioned we want to, our goal was to have 80 to 90% of, at the alpha to, going into beta program, Bladebit Disk beating madMAX across, greater than 80% of the systems. We're getting pretty close. You can see on the budget build, this is my i7 10700. We're able to do 30-minute plots on Bladebit Disk. This is using a pretty good SSD, but to show how it will, if you're CPU bound on this 8-core system, you don't really need super high-end SSD to max out the system. This system had 32 gigabytes of DRAM, one SSD, 30-minute plot times. Now the big jumps are on these servers. We knew madMAX didn't scale real well on some of these higher core count systems, and you had to run multiple instances of them and stagger them to get the peak output on these systems. The Cascade Lake is able to do a 10-minute plot with Bladebit Disk with madMAX. And that same system, even with this RAM, DRAM, TempFS, RAM drive, it was still 21 minutes. And so the Ice Lake, I don't know, some of the people in the comments were poking like, why, do you not know how to run madMAX? Of course I know how to run madMAX. We've been running it for a very long time. Uh, I don't know why it's such a stark difference on this Ice Lake, but it is for whatever reason. And this is the method with 100 gig TempFS and RAM disk, and then the Bladebit Disk is actually 7-minute plot time with disk plot. So this is the fastest system I've seen with Bladebit Disk. The Skylake system, this is my 6130. It's kind of like a low-end Skylake configuration. These are 16-core CPUs. Bladebit Disk is just edging out madMAX with a RAM disk. So I imagine we're kind of CPU bound here. And the Threadripper Pro, Harold actually has done quite a bit of development for Bladebit on a Threadripper Pro. So it's not like we care only about Intel systems or only about AMD systems. Like I happen to have a lot of Intel systems. Harold has a Threadripper. I now have a Threadripper and a 5950X, so I can do quite a bit of testing at least on the AMD side. Now the one system we are not beating madMAX on is this AMD 5950X. And I mentioned I just got the system, so we're going to basically dig in a little bit more. But the interesting thing we found already was that we are beating madMAX on phase 1. It's phase 3 that we're seeing some performance degradation compared to madMAX. So anyways, we're Harold and I are going to take a look and see what we can do. If there's anything, it might be related to the memory bandwidth thing I saw, that maybe AMD is not playing well with the type of memory bandwidth that we need. But I mentioned Threadripper Pro looks fine. It does look a lot closer. We're again, all in all, Bladebit Disk does seem to be quite a bit faster than madMAX on all the systems we've tested on. There will be a lot of new systems and new configurations that emerge as part of this beta program that I haven't thought about or I haven't had a chance to test yet. So I do have an idea based on, as you can see, I've done quite a bit of testing. I have an idea of where this performs well, and I think I'm going to come up with some of these system types that are kind of really good high output as far as terabytes per day at a low cost. So this budget build, I'm pretty sure we can build this budget build system for $500. That is 30-minute plot time on an 8-core CPU. Hopefully we can, as far as like bang for your buck, I think it's going to be super hard to beat that. But people are buying, these V3 and V4 servers are getting down to like $500 or $600 for these like, dual 14-core V3s or V4 CPUs, and so those are going to perform super good with Bladebit Disk as well. Some of these older systems. So I'm excited to see what people put together. And from there, again, if you're not testing it yet or haven't joined the beta program, you should go do that. And we will, I'm really excited to see what happens. So thanks. So if you want to start testing Bladebit, you can head on over to the Chia network /Bladebit/releases. We will eventually have the beta builds on the page where you can download them, and they'll have full support for Bladebit Disk and the GUI and all that good stuff. But right now we have the binaries, and if you go, basically if you want to test this on Ubuntu, you can just right click here, copy a link address, go into a terminal. Let's see if I can make this bigger here, and we can wget the link, and then you can tar-xbf the link, and then you'll have this binary here. Now when you have the binary, and you can do a help, and it will give you the help for all the commands. So one of the first things we want to do when we're testing the performance is a couple tests. We have some built-in benchmarks to Bladebit Disk. So if you, this system actually, you may have seen a post on Reddit of one of the large Chia farmers from Brian Freeman. He did a tour of his garage 13 petabyte farm. Brian mentioned that he had some spare 5950X systems, and I was looking for a 5950X system to do some of these Bladebit Disk benchmarks. That was one of the systems I didn't have before. So he was gracious enough to sell me a system for Chia. So I just got this thing set up yesterday. This is my brand new 5950X system. But if you want to do this, you can go to your Bladebit and you can do a help. And you can, if you wanted to do, like you said, it shows here, Bladebit help disk plot. It'll give you the commands for disk plot. Now, if what the one of the things we're going to do, and you can see here up here, these are the all the things you can do in Bladebit Disk Plot, but I'll show you kind of what to start with. But the first thing to do is really just start with a memory test. And this is basically what I've been doing on this system, and we're trying to debug some plotting performance on this 5950X. So this memory test should tell you kind of what this threaded memory bandwidth is going to be in actual plotting, because this is just using some memcopy commands. And if you see, obviously, if you do really small, like so if we say we did, 100 megabytes, let's see if that's actually doing this correctly. Yeah, you can see here, you can play with the sizes, 4 gigs, 8 gigs. And then ideally on a system that's operating correctly, if you scale the threads to the total number of threads, you'll get higher threaded memory bandwidth. So this system is a 16-core system with, so it's got 32 threads. So that's a good place to start. Now, a lot of people have memory configurations that are screwed up, like they maybe mixed DIMMs or don't have the memory frequency set correctly, or they're not fully utilizing the channels. On this system, it's a AMD 5950X is 2-channel memory controller, and there's 4 DIMMs, and they're 32 gigabyte DIMMs. We have 128 gigabytes total, and so this system is probably suffering a little bit. These are running at 3,000 megahertz, and they're doing okay. But I expected higher memory bandwidth. Now, if we run pass mark performance test on this, you'll see we get a little bit more. But that's one of the first things we run. The other thing is what I have is basically 2 Samsung 980 Pros here. You can see here. Two Samsung 980 Pros in RAID 0. This is what we're running as our temp directory. Now, if you do we have another benchmark called IO test. We can do threads 1 and say IO test. And then we can give it a size 16 gigs, and then we'll send it to my RAID 0 array. Now, when you do a test like this, that's like 16 gigabytes on a consumer NVMe drive like a 980 Pro, this is all getting cached in SLC. So the performance is going to look amazing. You can see here, 12 gig GIB a second, or almost 13 gigabytes a second, and almost 9 gigabytes a second write speed. Now, the write speed, I believe, on these is about 1,800 megabytes a second after the cache is exhausted. But this is just a quick test you can do. Now, if you wanted to do like a massive file size, or I believe there's some ways to basically reiterate the performance. If you want to do a longer test, you can do FIO and some real performance benchmarking. But this is just meant to have a kind of quick benchmark to see if there's any problems in your setup. So those are the first things to run. Now, if we screen here, my Bladebit, you can see the command that I had here that was going to run, and I'll just kind of show you. You have your farmer key and your contract address just like normal, and then you have threads. Here I have the total number of threads minus 1, so I have 32 threads in the system. I'm using 31 because I'm saving 1 for the IO thread, and then you type in disk plot, and then after you type in disk plot, then all the other then you can put all the other commands in. So temp directory 1, mount SSD, -B buckets is 64. So 64 buckets will be generally the largest performance for Bladebit Disk. On most systems, you'll have to test some different bucket sizes and see what's best on your system. And then --cache 99 gigs. This is, I mentioned, is a way to get some good performance. Now, if we're going to do a -A on this guy to give it a alternating. This is just an alternating method used with this cache 99 that reduces the requirements for the performance, so that we can reduce the total amount of cache required. And then the last thing is your final directory. And so when you hit enter, it'll start. So you can see here the max memory size for 64 buckets is 11.56 gigabytes. It might not use all that, and then we're doing 99 gigabytes of cache. So that total is less than 120 gigabytes. So we're good there. We're not going to run out of memory. And so from here, you can see it's actually we have the disk output for disk metrics enabled by default now in the alpha builds. so you can actually see the right throughput on these workloads during the actual tables. And so this is really important because you can see, if those numbers, if you're not using cache, and those numbers are way less than what you were getting in IO test, then that might be a problem. So these metrics will help us when we get the logs. We're going to be able to debug people's issues quite a bit easier because we'll have these. Now, if you look at dstat, for instance, the total bandwidth is not going to look anything like that bandwidth we just saw. And why is that? Well, there's two reasons. One is because a lot of this data is being cached in memory, so those writes are being cached. So the Bladebit disk is reporting the output of the actual amount of bandwidth. Let's see, Bladebit. And but the other reason is, so when you're reading these buckets, and the buckets are a couple hundred megabytes, you're going to read the bucket and you wait just for a tiny amount of milliseconds because that thread is waiting for the next command. This is a context switch, and then it switches from sequential read to sequential write. That little tiny time in between, if you're talking about gigabytes a second and you're moving files that are a couple hundred megabytes, you're going to move a lot of those files within 1 second. So something like dstat or iostat is going to report your bandwidth per second. This output here is actually going to report the actual time, the actual bandwidth the drive did, not counting the time that the drive was waiting for another command. So this is important because the drives will be getting a lot of bandwidth and then kind of waiting and switching back and forth. This is one of the nuances or interesting things about how Bladebit disk works, and it works really well on drives that have RAID arrays and things that have lots of bandwidth. Because you're moving data back and forth between DRAM and the SSD. And again, I mentioned it also works really good if you have this 99 gigabytes of cache. So with that, that's basically how to run Bladebit disk from the command line. You can run it in Windows, in Mac as well. There's a couple nuances if you're running it in the other operating systems, but just come on by the Chia plotting channel and Keybase, and people will get you helped out if somebody wants to try to run it. So thanks.